All right, looks like we are live now. Excellent. So hey everybody, if you're in here, we'll just talk casually for a couple minutes, trying to let anyone else who's maybe a few minutes late get in. But we figured Gonzo and I were talking what would be a kind of a relevant topic would be talking about our favorite first-person shooters. So we're gonna just casually start with that. Gonzo, what I feel like you would have played more shooters than me. What is your favorite?
Yeah. Well, right now I'm playing a lot of Battlefield 1. I usually like Battlefield quite a bit. It's like a nice combination of different types of, everything. You have vehicles, you have different types of classes, all that kind of stuff. And probably Doom. Well, Doom, Battlefield, like in general, and then probably Counter-Strike are my top three.
Okay. So is Battlefield 1, is that the World War One shooter that's been
Yeah.
out
Mhm.
recently?
Yeah.
Interesting. So World War One, I went through the phase probably a lot of guys do in like World War or like in high school. World War Two, World War One, loved that stuff,
Yeah.
heavy machinery and all that. But World War One was always my favorite. But I felt like it was an underrated war. Like it was real. It was at the end of that. Oh, all that to say, I can't. Is it a fun like shooter experience? I mean, everything was
Yeah.
loaded slowly for the most part, but it's fun.
Yeah. I mean, I really enjoyed it. I mean, it's not, I don't know if it's an authentic World War One experience. It feels more like a World
Mm,
War Two game because when you think World War
interesting.
One, you think trenches and slow, shooting back and forth and stuff
Yeah.
like that. But yeah,
Gotcha. Okay. Man, those are cool. I am very unoriginal in that Halo is probably the only shooter I really got into. Grant, I did see Omar mentioned GoldenEye 64. I played that, but I was pretty young. I've tried to go back and watch it I mean, play it in recent years. And man, that frame rate is so painful. I don't
yeah,
have any recollection of it being a problem. But yeah, I mean that's obviously a great one. And Omar claims to be a master killer with the Distovil, which I feel like I wish we could set it up online and test that claim. But I believe it without a doubt. So yeah, Halo. I mean, a lot of people like that game. I got caught up in it, so
all right. I
pretty
never really got
unoriginal.
into Halo myself. It's I don't know.
Yeah. So was it the popularity? Because I mean, I would completely understand that.
No, I don't know. It's just something about the way the controls, the way it feels. It just feels very artificial. I guess it doesn't
Yeah.
feel impactful to me. Like when I play a game like Doom, like every shot feels like really powerful. But in Halo, it feels Halo kind of reminds me of the newer Call of Duty games where it kind of feels arcadey.
Interesting. That's a pretty cool critique, thoughtful critique about
Yeah.
it. Never thought of it like that. And I don't play a ton of shooters, so in a kind of weird way, like that is my compass for what a shooter should be like. So kind of ignorant on my end. But cool, man. Well, I should check out the. I would really like to check out Battlefield because I loved World War One. I'd be curious to see how that plays and experience some of those battles. But cool. So we hopefully given a couple minutes for people to come in. If you're here, like go ahead and put in the comments like where you're from and maybe what your like discipline is here at CG Cookie or Omar, I see you a lot in the Blender stream, so it's cool to see you kind of crossing over into other disciplines. But yeah, so if you're here, let us know where you're from, and I don't know what you want to do with Unity or anything through CG Cookie. But I'll pass it over to Gonzo now to get started with the meat and potatoes of the stream.
Okay, so hi everyone. I'm the Unity instructor here. For those of you who don't know who I am, Jonathan Gonzalez. And in this live stream, we're going to be going over kind of like the workflow that I've been using and Kent and I have been going back and forth on creating a animated character for a first person shooter that we're trying to create. In this live stream, we're going to create more of a third person controller. We're going to see the full body. And you could modify what we're going to be going over in this live stream to be a full fledged third person controller. And that's something we've kind of discussed, including within the first person shooter. But this character is a fully rigged animated character, and we're going to be going over some of the basics. We're not going to go in depth with how I created what we have so far. For those of you who have seen some of the articles, the dev blogs that Kent has been putting out, you may have probably played a demo of what we have so far. We're going to be creating something very similar to that. So I'm going to be going over the project files first, and then we'll be going over the scripting aspects. I'm going to be going over creating the character controller. There are basically two different types of controllers that you can use with like moving around characters. That's a Rigidbody controller and a character controller. I was tempted to create a Rigidbody controller for this, but instead I just went with the character controller. It's a little bit easier to work with on my end because I'm more experienced with it, but either one will be fine if you're willing to put into work to create the controller. So I'm going to take a look at the files real quick. So I'm going to jump into Unity. Okay, so this environment is our like a little test environment. And this is the environment we're using to kind of replicate a smaller version of what we have for our much larger FPS environment. So we have the sloped area right here, so we can walk up slopes, or basically stairs in this case. We also have this little area that we can jump down, so we can test out jumps. And then in general, we just have walking areas. Let's take a look at the folders in here. So the environment obviously includes everything that you see in here. And we also have colliders applied already. We have the models, which includes the robot character. And I actually have two of them in here. I have one which is from the Sketchfab. Now, don't worry about the pink color. I did change some materials around so it looks like it doesn't have materials, but it does. So the one from Sketchfab actually has the idle state that I wanted to use because this character actually has a weapon that you can actually see that he's holding. It's a little bit hard to see, but you can see he is holding it. And if we play the animation, actually, I need to move my... I'll take a look at this little bit in a moment because I do have my camera currently in front of it. But we have the animations for the idle states, the running, and then we also have walking. Now the other character has basically all the same animations, but I did want to include a simple jump. So we're going to be using that from this guy. Now since both of them have the exact same rig, we can utilize the same animations for the one character I'm going to be using. I have a couple of scripts in here we're going to be using. I did pre-make these because they are a little bit more complex, but I will be going over these line by line. We have one which is going to be our aim IK. The upper body of this character is going to be controlled with IK. The rest of the body is going to be controlled by a character controller, and that's going to use a actual character controller component. And we're also going to have things like speed and jumping and things of that sort. So I'm going to get started by first dragging in the model. Okay, I need to apply the materials for this guy. I did change the materials around so it does look like he's pink.
Is this a .blend that's part of the project files, or is it an FBX?
So I'm actually using both. So the one that this robot anim 60 FPS, this is a blend file. I typically don't like using blend files a whole lot because they are a bit slower. So if I were to make changes to the animations, it would be a lot slower to update. The robot new right here, or the robo new, is an FBX file, and this one's a lot quicker. I typically like working with FBX files, but we've had some issues with like the animation's not working properly with FBX files. Either one part of the animation is erratic, maybe the legs are kind of moving in and out. So we've been using the blend files to kind of help alleviate that, and that seems to be working. But in general, I like to use the FBX files.
Oh, that's right. Yeah, we've actually had a lot of trouble with this. And I think you're correct in that, like when you bring in a .blend, doesn't it run the FBX importer in the background, and it exports anyway, just it makes it a little more seamless?
Yes.
We run into a problem. If you guys do it this way, I like the blend method because I get to edit it directly in Blender and I don't have to export every time. Like it's just cuts out a step. But if I have like a new experimental version of Blender installed on my machine, when I try to open that file in Unity, it tries to run the background export with the experimental version of Blender, and we get an error. And it took us a long time to figure that out. So anyway, to Gonzo's point, like using FBX is probably the smartest, the most error-free.
All right, so the first thing that I want to do is actually apply a script to this guy. This will allow us to control his movements. And we're going to be using a script within the scripts folder that I have already set up. So I'm going to open this up. Let me go ahead and switch to Mono Develop real quick. Okay, so at the very top, we have the character controller. This is a component that we need to use. So we want to include it in here as a required component. So what this does is it allows us to add the character controller component to our robot character if it doesn't already have it. And this also prevents us from removing it. So we don't want to add this script to our character and then we don't have the character controller and then we run into errors. So this allows us to add it on and prevents us from removing it. All right, so I am going to be using a lot of these like header and range attributes. They make them easier to organize things within my script, and also makes it easier to work with in the inspector panel. So this first section is just our character movement settings. And the first one is going to have a range between 0 and 10. This is going to show up as a slider within the inspector panel, making it very easy to adjust the settings. So we have a couple of speed settings, one for our walking speed and our running speed. Both of these are set to float values. So this will allow me to kind of create those in-between numbers. So maybe my walk speed can be, say, 6.5 instead of 6 or 7. This just gives us a bit more control. Same thing for our run speed. We have our jump power, which is pretty self-explanatory. This is going to allow us to jump. And then along those same lines, we have the gravity. So gravity and jump power are going to work hand in hand. And once again, these have range values as well, between 0 and 10. And with the range values, we can go between, say, an integer, so a whole number, or we can also use floats. Right down below that, we have the anti-bump and anti-hop. Now, the anti-bump, this is going to help us to prevent bumpiness when we're moving down slope. So with a character controller, the way it works is when you're moving down a slope, it's going to act like it's kind of going down a escalator. So the capsule itself is not going to rotate to the normal of whatever you're trying to traverse. It's going to stay upright the entire time, which is going to create a small gap below it. So when you're going down slopes, it thinks that there's nothing below it, so it's going to think that it's off the ground, and it's going to start bouncing up and down. So the anti-bump here is going to prevent that, and we'll be using that a little bit later on. Now the anti-hop is to prevent us from creating the bunny hop. I don't know if you guys are familiar with that, but bunny hopping is where you can basically jump around like a bunny in your game. And this is kind of like a timer letting us know that once we hit the ground, we're going to wait about 1 second. And here we can set this between, say, 0 seconds or 3 seconds. And after that, then we can jump again. So it's kind of like a timer for our jumping. Down below
Got a question. Sorry to interrupt you real quick. Omar asked a question. It's related, but I'm curious also what you know about Alembic, which is a file format. Have you heard of Alembic, Gonzo?
It sounds kind of familiar. I'm not entirely sure.
Okay.
What kind of program uses it?
So the question is from Omar, and he's curious. He's heard the term and wanted to know if it was related to games. And I wasn't sure if it was related to games. I know, which it seems like maybe it's not. As much as I know about Alembic is, throughout the computer graphics industry, studios they don't always use the same software. There are a bunch of softwares that they can use. So how do we make those communicate to each other? So you've got FBX, which is an attempt to make models and rigs, and I think lights and most of 3D elements be able to be exported, as opposed to OBJ, which is just a model format. Mm-hmm. And Alembic, from what I understand, is the latest cutting edge file format that's supposed to take everything from your 3D scene and be open. Any other program that supports that file format will be able to open it. So in theory, your entire Maya scene can be opened in Blender rather than just certain elements. So that's what I understand Alembic to be. And it would make sense that maybe that's a little too advanced for games at this point. But that's as far as I know, that's the best answer for Alembic that I can.
Yeah, I mean, I've never heard of it myself. I don't even know. I don't think Unity supports it. I haven't seen it. Unity supports all of the basic FBX, OBJ. There's a few others as well, like Collada or the blend files and all that kind of stuff. But I haven't heard of Alembic.
I don't know if it's been widely adopted yet either, but kind of trying to become that. It would be a hard thing to do to make it all compatible. But anyway, back to the jumping and stuff.
All right, so back to our jumping. So we want to have a bool here. This is a public bool. This will let us know if we're grounded. By default, it's going to be set to true because we are going to be on the ground. And basically, we're going to be using this to determine whether or not we're off the ground. This is going to be more important when we're determining whether or not we can actually move. So if we're in the air, we don't want to be able to move. I mean, you could add in air movements, but for the most part in this live stream, we're not going to have air movements. So when we're off the ground, grounded is going to be false. So we want to basically disable all movement. Now, when we're also off the ground, we can determine whether or not we're going to be playing a kind of like an airborne state, like an airborne animation. We're also going to be using this with our jumping. So when we jump, we're going to be toggling this on and off. Down below that, I like to keep all my private variables in a nice little group. So these are all the private variables. We're not going to see these in the inspector. We're going to have our move direction. It's going to be a vector 3, so we can move along the X, Y, or Z position. And we're going to start off at vector 3.0, meaning we're not going to be moving at all. We're just going to stay where we're at. We have a private float speed. Now this is going to work in conjunction with our walk speed and our run speed. And the reason why is because there are going to be instances where we're going to be walking and then we can also run at the same time. So we're just going to be using this one variable right here. And then we're going to be switching out the run speed and the walk speed and assigning it to this guy right here. Down below that, we have our jump timer, and similar to our speed, this is going to work in conjunction with our anti-hop. So we're going to be incrementing or decrementing our jump timer based on whether or not we're jumping, and we're going to start off by assigning the jump timer to our anti-hop. We have a reference to our character controller. And I did comment this out because this is relating to our animations. We'll come back to this a little bit later on when we add in the animator and we go over all the different animation states.
Kind of a noob question from me, Gonzo. What is like private float or integers versus the public? What's kind of a layman's explanation for
So
that?
public allows me, like this is a class. Public will allow me to access this from another class. So maybe I have another script that wants to reference this script, and then I want to adjust something in here. So maybe I want to adjust the walk speed. Maybe like there's another class that I have that's maybe taking damage. Like if there's damage applied to my character, I want to do something. Maybe that class references this class and adjusts the speed. So maybe if I'm hurt, I'm going to reduce the walk speed even further to make it slower. Okay. So private basically means that I am only keeping it to this specific class. I don't have access to these variables from another class. This is also not going to show up in the inspector. So if you're working with like a team, like if, for example, if I give the script to you and I don't want you to adjust any of these right here, I'll set them to private so you won't see them as well. So you can only adjust these that are public, and these are the only ones that will show up.
I gotcha. Okay, that makes sense.
Yeah, and there's more to it than that, but that's the gist of it.
Right. Okay. Makes sense.
Okay, so like I mentioned before, these are the character animation settings. We'll be coming back to this a little bit later on. Down below that, we have camera settings. So up until this point, basically everything in here is for just the general movement of this character, moving in and out, left and right. But that's just going to be the actual character moving around. We also want to be able to aim with our camera. So I included a section here for the camera settings. We need a reference to our camera, which I'll be using as a transform. Then we're going to have sensitivity and smoothing for this. So the sensitivity is how fast we're going to be moving that camera, either left and right or up and down. And we're also going to have smoothing to help smooth it out. And then we're going to be using a couple of values here, max Y and min Y. And these are both going to be float values, so I just had them in line like this. But this is going to be used for clamping the angle value of our camera, so moving up and down. I don't want to have the ability to move my camera all the way around. So we're going to have a couple of values either between, say, 20 and negative 20 to move up and down. And once it reaches that point, it's going to stop, so in either direction. Now this is optional. I added this in here for myself. This is mostly for kind of testing purposes. So this is a public bool called lock cursor. And basically what I'm going to be doing is, if I have this enabled when I first start my game, I'm going to set my cursor to lock, which is going to move it to the center of the camera and lock it into place. And then I want to disable the visibility of that cursor so we don't see the cursor. But if I set this to false, we're not going to be going through this. And the reason why I want to have that in there is because if I need to make changes to the script in the inspector panel while playing the game, I can easily go in there. Otherwise, I have to press escape and try to find my cursor and all that kind of stuff. But once I've made those changes and I just want to test out my game, I can then set this to true and lock my cursor to the center. Now down below that, we have two vector 2s. We're not really concerned with moving along the z-axis for our camera. I just want to move either left and right or up and down. So we're going to be using a vector 2, which is going to be the x and the y-axis. We're going to have one for smoothing, and then we're going to have one for our actual mouse looking. Okay, so in the start method, we're going to grab our character controller, and we're going to assign it to our controller variable. We're going to start off with our walking speed. And the walking speed right here, or the speed variable, is going to be determined based off what you want to do with your character. So in our case, I want to set it up so that running is the default speed. Not running speed, walking speed. You could have it set up so that the default is running speed. In this case, you would set that to run speed. But in this case, I'm going to set it to walk speed, and I want to have the run speed based off when we're holding down shift and also moving at the same time. We're going to set our jump timer equal to anti-hop. So anti-hop is kind of like our timer, and we're setting that equal to our jump timer. I have a reference to the Animator, which we'll be using a little bit later on, and then I've already kind of gone over this. Right, so in our update method, we're just going to be continually updating two different types of movement methods. Movement right here is going to be for our general movement of our character, so moving forward, backward, left, and right. Camera movement is going to be controlling the camera movement, so aiming our camera around. So let's take a look at the first method in here, movement. And take a sip of water real quick. Okay, so first off, we're going to have a couple of local variables. One's called input X and input Y, and as you can guess, this is going to be for the X and Y axis. And we're using get axis raw. Now we're going to be using this a little bit later on for our mouse as well, but basically what we're going to be doing here is we want to get the axis of the horizontal and vertical, and that's going to be our keyboard keys on our keyboard. So the WASD keys. So for horizontal, that's going to be A and D. And then for vertical, that's going to be the W and S key. And we're going to store that within our floats over here. We're going to be going over this a little bit later on when we take a look at animations. Now here we're checking to see if we're grounded. So remember, grounded is our bool. And with it set like this, that means is if grounded is true, then we can do all of this. So if I just kind of add my cursor right behind this curly brace, you can see where it ends over here. So everything in here is going to be based on whether or not we're grounded. Now, if we're grounded, if it's true, we're going to first check to see if we're holding down left shift. So input.getKey. Get key means we're holding down a specific key, and that specific key is going to be left shift. Now, if you're using a controller or you're using multiple inputs, you may want to change this out to be a bit more dynamic. So you may want to have a specific input that's called run or something of that sort. In this case, this is hard-coded to my keyboard, so I'm only looking for left shift. Now, if it is left shift, if we're holding it down and we're moving forward, then speed is going to be equal to our run speed. Now, when I let go of that left shift key, we're then going to be doing this. We're going to be resetting it back to walk speed. Now, we're also going to be moving our direction. So move direction is a vector 3. And we're going to be setting that equal to our movement along the horizontal and vertical axis. So everything that we set up here, we're now going to be plugging in here. So remember, this is the X, Y, and Z axis. So input X is going to be our X axis for our move direction. So if I'm pressing the A or D keys, we're moving left and right. Anti-bump right here, this is where we're talking about the bumpiness of going down slopes. So we're going with a negative value for our anti-bump. If we jump back up to the very top, we have our anti-bump right here set to 0.75. And basically what this is going to be doing is it's going to be pushing our character down so he's not trying to bump. So with a negative 0.75, that's going to be along the y-axis. We're pushing our character down. And that's why we have a negative anti-bump. Now the input Y is going to be for the Z-axis. Now the input Y in this case is going to be our W and S keys. So that's going to be moving in and out. Remember, the Z-axis is pointing forward. So our character is going to be moving forward based on the W and S keys. Now the next line is basically doing something similar, except we're now multiplying that by our speed so that we can actually move based off the speed variable that we've set up here.
Gonzo, I've got a question for you.
Mm-hmm.
Whenever you're putting this together, obviously this would be a lot to write out in real time. But are you building this gradually, or do you build the entire kind of skeleton that we're seeing first and then in script form and then go back and like you have inputs that you can plug in at that point? Or do you kind of build it going back and forth over time?
I build it back and forth over time. I mean, obviously I'm not going to if I could build the entire script at once, I would. But usually it's a lot of going back and forth. Like, oh, I want to be able to do this when I press this button, but first I want to check to see if it works without doing that first. Then
Definitely.
like for example, I may have just started off with one speed, which was just the walk speed, and then I want to implement the running later on. So then I add in this if statement to check for a specific button input, and then I can change the run speed, all that kind of stuff.
That makes sense. Okay. Yeah, I figured so. You just seem to know this so well. I wondered if you kind of did it all in one go.
No, yeah, no, definitely not. And a lot of these scripts that I have too, I like to save scripts on my computer, like little code snippets. If I find something that I know work really well, like maybe I'll find a code snippet for just running. So maybe I just found this online and I said, oh, that will work for my character. Or maybe I just found this section right here for jumping. I'm going to add that in and just kind of combine it, kind of like a puzzle.
Right. That makes sense.
So
that's really smart. It sounds like to work that way.
Yeah.
So I have a question from Omar about to you. He's asking, Jonathan, do you think I can make interior visualizations for presenting architecture work to clients without getting into the coding part of Unity?
I mean, that's kind of a vague question. I would say it really depends on what you're trying to create. Like if you just want to be able to move around within a pre-rendered scene, it's very, very easy. You can have everything that I'm doing right here, Unity has its own prefabs, like a character controller that you can just drop in. You don't need to know any of the coding or anything of that sort. If you do want to build it, you can obviously create your own scripts like this, but they do have their own presets or prefabs rather for just dropping it in and being able to do all that kind of stuff. So if that's just what you want to do, then it's very, very easy. But it really depends on how interactive those visualizations will be.
Right. Have you, Gonzo, because I think Omar comes from the Blender side mostly, and I can certainly understand wanting to do that with the real-time, nature of Unity. But I would say that if I were imagining myself doing that, there's not a lot of traditional animation tools within Unity. So like if I wanted to animate a camera fly through Unity, like that would be pretty hard to do with the current version. But aren't they working on, isn't Unity like actively developing a more like animation friendly part of Unity to allow like short films to be made and stuff like that?
Yeah, and that's something that I'm probably going to teach in the future. They have this new timeline feature. It's really good for like cinematics. So they just acquired this asset called like Cinemachine, and Cinemachine with timeline allows you to create something very similar to what you might find in Blender. So it's I kind of think of it as almost like video editing, but you're using real-time animations. You could have scripts and all that kind of stuff happening at once, and it gives you a lot of control for that kind of stuff. So if you want to be able to create that kind of stuff, it's going to be a lot easier in the near future.
Okay. It looks like Omar clarified he just wants to be able to move around, and I assume that means in real time. Mm-hmm. So he probably could use like a prefab that comes with Unity and like attach his camera to it and get that behavior probably, right?
Yeah, I mean, you don't even have to attach the camera. It comes with a preset, like a first-person controller that's already pre-made.
Oh, with the camera inside of it. I gotcha.
Right, and you just drop it in and that's it. You can play around with it, within minutes. So really the hard aspect is getting your visuals to look really good in Unity. So, setting up the lighting, all that kind of stuff, that's something you'll have to learn. But other than that, it's pretty easy.
Cool. That's a good answer.
Okay, so we went over the moving. So this is going to allow us to move in a specific direction based off the inputs that we have selected. Down below that, this is kind of almost reversed. So this is going to be used for our jumping. And here we're checking to see if we're not using the get button jump. So this is the input. In this case, that's typically going to be your space bar. And this little exclamation point right here basically means we're doing the opposite. So if we see this in front of something, that means if we're not doing that. So if we're not holding down the jump button, which is the space bar, then we're going to be incrementing our jump timer. So this is if we're on the ground and we're not holding down jump. Now, if we do press the jump button, if we're holding it down or just pressing it once, we're first going to check to see if we're on the ground long enough that our jump timer is greater than or equal to the anti-hop value. So remember, that's going to be 1 to start off, but you could increase that. So once we hit the ground, we're then going to be incrementing that value. And if this value is less than anti-hop, we're not going to be jumping. I do have a line in there that is commented out right now. This is for our actual jumping animation. So when we press jump, we're going to be playing the jumping animation. And then here, this is where we're actually going to be physically moving our character up. So we only want to move our character along the y-axis. Remember, that's the up and down axis in Unity. So we're going to be jumping up based off the jump power. Now, when we're in the air, or once we've gone through the jumping state that we have here, we're then going to be setting jump timer back up to 0. So that way when we land, we're going to be incrementing that up again. Now down below that, we have a section for gravity. With our character controller, we don't really have the same physics type of environment that we would have with the Rigidbody. So we kind of have to fake it. So here we have the move direction.y, and we're going to apply gravity to that. So gravity is our own custom value. And here we have minus equals. So wherever our move direction is, or the y-axis is for our character, if we're in the air, for example, and we're coming down, this is what's going to create that gravity for us. So we're subtracting the value of our y position based off the gravity, and we're multiplying that by time.delta time. This is going to help us to kind of smooth that value as we're coming down. Down below that, we have our grounded. This is our bool, and we're basing this on whether or not we are actually hitting something, hitting a collider. So all this right here, all it's doing is checking to see if we're actually on the floor. So basically what we're doing is saying, hey, have we hit something? Are we on a ground? Are we on stable ground? Something of that sort. If so, we're going to be setting this to true. If we're in the air, this is going to be set to false. Now here, I'm not sure if we're going to be using this in this live stream. This was used with our own character, and this is going to be used to determine whether or not we're playing a airborne state. So this is an animation that plays an airborne state while we're in the air. Okay, so now we're going to be taking a look at the camera movement. Up until now, we've been covering everything to allow our character to move along the WASD keys, but now we need to actually aim our camera. This is also going to help us to rotate our character based on our mouse movements. Now, with our mouse movements, all we need is a vector 2. We're not going to be using the z-axis at all, so a vector 2 is going to be the x and the y position. So we have a vector 2 called mouse direction, and we're setting that equal to a new vector 2. And here, once again, like I mentioned before, this time we're using getAxis raw, but we're using a input of mouse x and mouse y. Up above, we use horizontal and vertical, which is our keyboard keys, but now we're using mouse x and mouse y, which is the mouse horizontal and vertical movements. So this first one right here is the x-axis and the y-axis, and we're storing that within our one mouse direction. Down below that, we're going to be using our mouse direction, and we're going to use vector2.scale. This is going to multiply our two vectors, and this is essentially going to help us to smooth out the movement of our camera movements. Smooth V is our other vector2 value, and we have one for the x and one for the y. And we're going to be using mathf.lerp. Now, lerp is linear interpolation. Basically, we want to move from one point to another point, and we want to smoothly move to that new point. This is going to create that smooth motion. If we didn't have this in here, what's going to happen is as you move your camera, if say my camera is over here and my character is facing this way, when we go to move, it's going to instantly snap to that new position. So this is going to help us to smooth that direction along the x and the y position. So we have the smoothv.x. This is where we're currently at for both the x and the y. This is where we want to go to, which is our mouse direction. And then we have here the smoothing. So we're saying if we kind of hover over this, it'll make a bit more sense. But we're linearly interpolating between A and B by T. T is going to be this last value right here. So that's going to be 1F divided by our smoothing value. We're going to be adding that to our mouse look. So mouse look plus equals smooth V. And then finally, we want to clamp this down. So like I mentioned before, we want to clamp down our values for the Y position moving up and down. If we didn't have this in here, what's going to happen is I can push my mouse all the way out and the camera is going to turn all the way around. So we want to be able to clamp this only along the Y position. The Y position is going to be moving up and down. We don't want to clamp this along the X position because we want to be able to rotate all the way around without being stopped. So we're saying mathf.clamp, and once again, we're using just the Y axis. We have what we want to clamp down, which is the Y position. And I'll just kind of hover over this so you guys can see what it says. So we have what we want to clamp down and the min and max value. So min y and max y. So this could probably be about 20 and negative 20. You can change it to whatever you like. All right, so we've already set up our camera movement, but now we need to apply that to actually rotate our camera and our character. So this first one is our camera. This is a transform. So cam.local rotation. We're going to set that equal to our quaternion dot angle axis. So here we have what axis we want to move along, which is the y axis, and we're using negative y because if you leave this out, it's essentially going to be inverted. So if we're looking up, it's actually going to move down and vice versa. So we're going to be using the vector 3.right, which is actually the x-axis of our mouse. So if I'm moving left and right, hold on. Sorry, let me rephrase that. This is going to be the x-axis of our camera. So it's a little bit hard to see right now because I don't have the visuals, but the y-axis is moving up. We have the x-axis horizontally, and you can kind of think of that as a pole. So if we were to think of this as the x-axis, if I'm moving up and down like this with my mouse, I want it to turn in this direction. So that's going to be the x-axis. If this is the y-axis and I want to move left and right, it will be moving left and right like that. So vector 3.right is going to be our x-axis of the mouse, and we want to base that off the mouse look.y. So that's moving up and down on our mouse. And once again, we're using a negative value to invert what we have. We're doing the same thing for our character. So transform.local rotation. We're applying this to our robot character. So we're using the transform of that robot character. And we're basically doing the same thing as up above. But this time, we only want to move along the y-axis. So transform.up is the y-axis. And moving my mouse left and right, which is going to be the z or the x-axis. And that's going to be applied to our y position of our character. So hopefully that makes a bit of sense. It's kind of, we're using one axis to affect another axis. And then down below that, I'm not going to be using this, but this is kind of more of a simplified version of what we have up here. So we're using the character's rotation right here. We're saying transform.rotate. And I want to rotate along the y position of this character. And I don't want to rotate along the x or the z axis. So input.getAxis mouse x, once again, that's our horizontal, and we're multiplying that by our smoothing. So when I move left and right, it's going to be rotating along the y axis. We're doing the same thing with our camera, but instead we're rotating along the x axis of the camera. And once again, I'm using a negative value here to invert what I have. We're not rotating along the y or the z axis for our camera. Okay, so that's basically the gist of our character controller. We're going to be using this to control our character. I'm going to go and switch back to Unity.
It's a pretty big script, Gonzo. How would you say it's big, or
No.
do you usually write much more? That's nuts.
Yeah, I would consider that. I mean, that's an okay script, I guess. So I have another script in here called A-my-K. We're going to be using that when we take a look at the animations. For now, let's just apply the character controller to the robo. All right, so once I add this in, it's going to add the character controller for us. I'm going to make some adjustments to the character controller. And I think I'm going to turn off my camera for now because I think it's blocking the character controller. Okay, so this little green capsule here is our character controller. I'm going to adjust the radius and the height, and I'm also going to adjust the center. Let's go with 0.25. I think that's wide enough. 1.25. And I want the character controller to be right at his feet right here, so I'll probably move this down a bit. And I need to move this along the z-axis here as well. Okay, so I think that's fine. I'll probably move it up just slightly so it's not stuck in the ground. Okay, so it doesn't need to be perfect. This is really mostly for moving him around. And we do want to detect collisions, but it doesn't need to be perfect. Okay, now what I want to do is I want to move my camera behind him like this. So just get into a good view in your scene. And then I'm going to select my camera. I've already parented the camera to the robo, I believe. Or maybe it's in the environments. Let me go and find my camera real quick. Or maybe I don't have a camera in here. I'm going to add one in anyways. There we go. Okay, so to easily move your camera into view, just get a good view in your scene. Select your camera. Then go up to Game Object, Align with View. And sometimes the view itself is a little bit different than what you see in the scene. Move this in a little bit closer. Okay. I'm going to move the camera as a child of the character. So that way the camera follows our character around. And now we can go into our script once again, and we need to assign the cam of the camera settings. Okay, so let's take a look at some of the settings in here. By default, I do have the walk speed set to 6. The run speed is set to 10. So we can adjust these further if need be. I think the walk speed by default is probably a little bit too high, but I'll leave it for now. The jump power is 3, which is a little bit low. And the gravity is also kind of a little bit low. We have the anti-bump set to 0.75 and the anti-hop set to 1. If you want to create more of a delay between jumps, you can increase this. And then grounded is turned on by default. The camera has been applied. The sensitivity is a bit high. I'll bring this down to 3. And the smoothing is set to 2. Now for the max Y and the min Y, this is going to allow us to clamp the value for our camera moving up and down. I'm just going to set this to 20 and -20. All right, let's give this a quick test. I'm going to hit play. Okay, so we don't have any animations right now, so he's just going to stay in place, but I'm moving with my mouse. I can look up and down, and you can see that value right there is probably a little too high, so we can bring down the max Y. But if I press W, I can move forward, and I can also turn simultaneously. I can also jump. So you can see that jump is a bit floaty. So let's adjust some of these values. I'll bring down the walk speed to 4. Let's see, the jump power, I'll bring this up to 5. The gravity, I'll bring this up to 10. And let's see, the sensitivity is fine. The max Y, we'll probably bring this down to 10. And I think we're good for now. Let's go and give this a quick test. All right, so the sensitivity might be a little too high. Walk speed's a little bit better.
What's the sensitivity again, Gonzo?
That's for the camera. So if I'm moving left and right, you can see how it moves very, very quickly. So
yeah,
if I bring this down to say 1, it's going to move a lot slower. So you have to, I'm using a trackball myself, so I have to spin the ball a bit more to actually move around.
Right.
If you're using a regular mouse, you may need to move your mouse around more.
And I'm pretty much a Unity noob as far as programming, certainly, but it's really cool to see you plug all those code lines in and then get this. Do you still get a big kick out of that, having done this for many years?
Yeah, it's a lot of fun seeing these characters come to life, from essentially text on a document.
Yeah, absolutely. That's so neat.
Okay, I'll try this out as well. Now, one thing to note, as you can see right here, my values did reset. So if you do make changes, you don't want to be in play mode, or you want to at least remember what changes you made, because they'll reset when you're out of play mode. So for the walk speed, I'll set this back down to 4. The jump power, I think, was 5. The gravity was 10. And let's see, the sensitivity, I'll leave at 3. I'll set this down to 10. I'm going to try this again, and I'm going to click on lock cursor. So what that's going to do is my cursor is going to go straight to the middle and then disappear. All right, so I no longer see my cursor, and this makes it easier to kind of navigate around. don't have to worry about clicking something outside of the game window. Okay, so we have some basic navigation with our character. We can move around. Now let's add in some animations for this. So I'm going to take a look at the robot model. I'll start off with this one first. This one has all the animations I want to use. Then we'll use the jumping animation from the Robo New. Now, one thing to do when you first import a character, like a humanoid character, is you want to go into the rig section. Right now I have set these up as humanoids, but by default it's going to be set to generic. And generic is going to be for any type of generic rigged character. Now the reason why you want to set this to humanoid is because in our case we want to set this up with IK. And you could use generic IK, but it is a bit more work. But with humanoid we can also use different animations from other humanoid characters. So for example, if this character was set to a generic character and I brought in another robot character that had a slightly different rig, I can no longer use the same animations for either one of those characters. But if they have a humanoid rig, they both have a humanoid rig like we do in this case, I can use all the animations together simultaneously. This is very important if you are working with a lot of different human characters and they have very similar animations. So once you have that set up as humanoid, you then want to go and click on configure. You may have to hit apply first. So I'm going to save my scene. Give this a few seconds to load. Yeah, it's taking a long time because this is a blend file.
Yeah, you mentioned that earlier. I didn't realize that they took so long.
Usually it doesn't when I'm first configuring this. It's usually when I'm making adjustments to the animation. So when you start off with the configuring section, you should see something similar to this. So he should be in a T-pose, and just about all the bones that you want to use should be green. So if you take a look at the section over here, all the little dashed lines right here are the bones that are kind of optional. We don't need these bones, but all the ones that are solid lines, you need to have those in there. So if you're missing any one of those bones, you're going to see a red portion, and it's not going to allow you to utilize a humanoid rig. Because when you use a humanoid rig, Unity is essentially duplicating that rig and using that as the rig for your character. And that's why it allows you to utilize other humanoid characters, animations. So I'm clicking done for that. Let's take a look at the animations real quick. All right, so we're going to start off with the idle state first. And you can preview it here. Now this animation actually loops very, very well, but we can set this to looping in here as well. So we do that by clicking on loop time and loop pose. I'm going to pause this real quick. So once you make any kind of changes to animations, if you're just making a change to a single animation, you can click apply. But if you are making changes to multiple animations, you can then make those changes and then hit apply at the very end. So I'm not done with all the other animations. I also want to use my running forward and walking forward states. Now I think we're a little bit low on time, so I'm just going to focus on the walking. So for our walking, you can see what that looks like. We also want to be able to loop this as well. So we'll set loop time and loop pose checked on. And I want to duplicate this because I want to create different movements for the angles. So if I'm moving to the right or the left, I want to move in a horizontal or a 45-degree angle using the same animation. Now we don't have those animations in here, but you can duplicate them and you can change the offset. So you can duplicate by clicking the plus icon here. And I'll rename this to robot_walk 45. And we only need to create one of these. So I can just create the one going to the right. I'll set this to loop time and loop pose as well. And down right here where it says root transform position, I'm going to set this to an offset. Actually, I believe it's this one. Let's see. I don't know why it just disappeared like that. We'll go and try the other one. There we go. So this is the default. It doesn't really matter which direction you go in because we're going to be mirroring this. So now he's going to be walking at a 45-degree angle. And the reason why we're doing that is because we're going to be using it with a blend tree. So we have that set up for 45 degrees. And I'm also going to be creating a, actually we can use the backward walking animation as well. Oh, we don't have a backward walking. I'll duplicate the original walking cycle and I'll reverse that. Actually, I can do that in the blend tree, so I don't need that in there. I just need the 45 and the original walk. So once I'm done with everything, I'm going to hit apply. It's taking a while to update. Okay, it's done. Okay, so we need to plug in those animations into a animator controller. So let's create an animator controller. I'm just going to create it in the same robot character folder. I'll just call it Robo. Double click to open it up. Okay, so we're going to be creating a blend tree, a 2D blend tree, which will allow us to move in any direction that we want. So I'm going to right click in here, create state, and we're going to create from new blend tree. All right, we'll double click to open it up. The blend type is going to be a 2D freeform directional. Freeform directional is going to allow us to add multiple animations along one specific axis. This will make a bit more sense when I open this up. We have a couple of parameters. So these are going to be the horizontal and the vertical axis. We can add new parameters by going over here, clicking on parameters, and you can see we have one default, which is called blend. I'm going to change this out, so I'm going to rename this. So we'll call this, let's call it horizontal. And that's a float value, so we'll add in a new one as well, which will be vertical. And just to make this easier to read in our script, I'm going to add in an _F. That's for float. And these are case sensitive when you use them in your script, so make sure that you type it out exactly the same way in your script. Now we need to add in motions, which are going to be our animations for all the different directions we want to move in. So we have one forward, we have one at an angle, we have one going to the sides, and we also have them going back as well. All right, I'm going to start populating this. So the first one is going to be our idle state. You can find the animations in the original prefab that you imported. So the idle cycle B, that's the one I'll use. I'll just drag this in here. Let's make sure that that's the correct one. Okay, so for the POS X and Y, basically we're looking for a value here. When we're pressing our inputs, we're going to be adjusting both the horizontal and let's also change this to vertical, but we're going to be adjusting these values here. So as we're moving forward, we're going to be adjusting the vertical value. As we're moving left and right, we're going to be adjusting the horizontal value. Now, when we're in idle, we want to check to see if we're both at 0 for the X and a Y. So that's why we're going to have the idle state set with 0 and 0. And here, this little clock icon, this is the speed of our animation. Next, we need our walking forward. Now, for this one, we're not going to have any kind of movement along the x-axis. We just want to have a positive one along the y. Now, if you want to preview this, you can hit play down below. So this is the idle state, and then you can move this little dot around. So if I move it forward, you can see it starts walking. And with our blend tree, we're blending between these two different states. Now, if we want to walk backward, we can add in another walking forward state. There we go. And I'll set this to 0 for the X and -1 for the Y. Now we also need to reverse this. So for the time here, we'll set this to -1, and now it's going to play in reverse. So walking forward and then walking backward. Let's add in our 45. So we're going to have 2 of these because we want one for each direction. So one is going to be moving. Let's go and select this one right here. I'm going to move it about right here. Then we can adjust the values a little bit later. So right about there will be fine. And then for the other one, it's going to be on the opposite side. So I'll set this to negative 0.6. And I'll just make this 0.6 to keep it even. And I believe that animation is going to hit play. Get a better view here. So that one's about right. If you think of this little view here, this little graph, as kind of like a top-down view, we're moving to the left right here. This will be the going right, and you can see he's still playing that same left animation, so we need to mirror this. So it's this one right here, and to mirror it, you want to click on this little checkbox. So this little icon means we're going to mirror that animation. So walking forward, walking right, walking left. Okay, now I want to add in, let's see. I think that's it for now. I'll remove this. Let's go and give this a quick test with our script so you guys can see how this works. So I'm going to add in the controller. I'm going to uncheck apply root motion because we're going to be controlling the motion of this character with the character controller. I'm going to jump back into the script real quick and we'll take a look at how we can adjust that further. Okay, so we need a reference to our animator. I'm going to uncomment out all this area right here. So the animator is the one that we just created. We need a reference to that so we can access the animations within the blend tree. And this right here is going to help us to smooth out our animations. So we're calling it animation smoothing, and this is going to be a float. We'll jump down to our start method. We need to grab our component. So anim equals anim.getComponent animator. And we're saying anim dot because we're going to manually assign this and we want to grab the component off whatever we assign to that variable. Now in the movement, I want to set the float values that we set up as parameters. So that's going to be anim.setFloat. And what do we want to set? Well, we want to set the vertical F and the horizontal F based off our input Y and input X that we have set up here. Now, this means that along the vertical F right here, we're going to be walking forward or backward. So if I press W, we're going to be moving forward and playing the walking forward animation state. Now, animation smoothing, if I just kind of retype this out, so here we have the input Y. Here we have the damp time and the delta time. Now, if we don't have this in here, we're going to get very erratic movements moving back and forth between the different states. So damp time and the time.delta time here is going to allow us to smooth those blending of animations between different directions. So we're doing that for both the horizontal and vertical movements. We don't have any jumping right now, so we'll leave that commented out. And we're not going to be using jumping with this, so we'll leave that commented out as well. And I believe that's all we need. So let's give this a quick test. We'll save that out. I'll switch back to Unity. Okay, there we go. It updated. We need to assign our animator. Now we could set it up so that we have the animator automatically applied. But in this case, I didn't set that up, so I'm just going to manually assign this. Now, I'll leave the animation smoothing at 0 for now, and we'll see the effect of how this works with our blending. So if I press play, He's in the idle animation state. If I press W, he starts walking. Now we need to adjust this further because as you can see, it looks like he's kind of sliding around. But now we have some basic movement with our animation synced up. Now let's take a look at how this works with our animation smoothing set up. So I'll bring this up to 1. And now you can see it's very, very slow to transition. So we can bring this down to say 0.25. And it's a little bit better overall, but that's something you have to kind of continually tweak to get something that you like. Now it looks like his walk speed is a little too quick for the animations. So we can either increase the speed of the animations or decrease the walking speed. So I'm going to do that here. I'll set this down to 2.5. And it looks like his right turning is not playing properly.
By the way, Gonzo, it's 4 o'clock, so just
Okay.
FYI. We'll end with some questions once you're done tweaking and stuff.
Okay, yeah, I didn't cover quite as much as I wanted to, but I guess I'll start with the questions now. If anyone has any questions for now.
I mean, it's really cool to see. Gosh, I mean, how much it's very easy to take that stuff for granted, like just moving a character around. And I remember when we were working on this for the game project, like just being blown away by how much work is involved. But wow, I mean, that's pretty cool. So I went kind of quiet on you, but like we were having a pretty good chat over here on the site, and we got a member. I think I'm not sure if I'm sure I'm not going to pronounce this right, but Giulio Solito is a member. He's been with us for, he said, 3 days, and he just finished his first game in February, and so he's kind of here for the whole thing, 3D game asset creation, but also Unity and game production. So we've just been talking back and forth, and pretty excited to have someone like that, watching the stream and being involved. And yeah, we're going to check out your game, when we jump off. So that's pretty awesome. But
yeah.
So yeah, we've been talking a lot, but I don't think there were any specific questions. We were going back and forth a little bit about coding and like kind of how games are such an interesting application of coding, and then seeing like the actual results. So talked about that a little bit, but yeah. So if you guys have any questions, let's see. We got one from Giulio, and please forgive me if I'm not pronouncing that right. Is there any reason to use character controller over a Rigidbody?
Yeah, I guess there's a lot of debate online on whether you should use a Rigidbody or a character controller. Personally, for me, I think either is fine. It just really depends on how much work you're willing to put in. The character controller is great because it allows things for like slopes. That's already built in. It kind of has its own pseudo physics, but you can control a lot of the movement better with the character controller. But again, you don't have the same physics as the Rigidbody. Now, the Rigidbody is good because you have the built-in physics. You get all the gravity, all that kind of stuff, the collisions, all that works perfectly, but you don't have things like slopes. You don't have the same type of control over the character in terms of how you're moving around. So a lot of people like to say, well, the character controller requires a lot more scripting and all that kind of stuff, but I also think that the Rigidbody requires the same amount of scripting. So I think Unity themselves actually recommends using the character controller over Rigidbodies, but I've also seen a lot of high-end assets use a Rigidbody-based controller. So I think it's really up to you on how much of the physics you're going to depend on.
Makes sense. Is Rigidbody like a newer? It seems like that would be a more advanced kind of take on the character controller. Is that right?
No, I mean, I think it's been around about the same amount of time. I think the character controller was created to mimic a lot of what the Rigidbody controller could do, but have a bit more, how to put it, a lot more control over smaller things. Like, for example, on the character controller here, we have the step offset, the slope limit, that kind of stuff.
Yeah. Okay, I'm with you. Wow. Let's see. So I'm looking through the questions, see if we have any more. Cool. Guess it would. Darren is saying, guess it would depend on where it's being used. That's probably true. Awesome. Well, yeah, cool, guys. I think we're gonna end it there. But thanks, Gonzo. Thanks for taking us through that and showing us your skills in Unity. I think there were at least a few of us who were pretty blown away by seeing that in real time, and
Yeah.
just the amount of work. I still can't get over it.
Yeah.
But awesome, dude. All right, we're gonna close that. Thanks for being here. The first Unity live stream that we've done so far. So we'll keep rolling with it and try and make it as good as it can be. But thank you for being here, and I guess we'll see you next time.
Yeah. Thanks a lot, everyone.
Cool deal. I just ended the stream on the site, so you can end the broadcast.
Okay.